Customers are actually expecting miracles, right? They're expecting self-learning, self-healing systems. The common perception of ML is actually that you just collect a lot of data, then you have some fancy, miraculous models, and in the end you have a magic result in no time.
ITCS, Pizzatime Podcast. Cheesy questions and juicy answers for the tech community.
Hi und herzlich willkommen zum ITCS Pizzatime Podcast. Heute mit Eric Ballnath von Google. Er ist Customer Engineering Manager und seine Keynote heißt AI for All. Kleiner Hinweis, diese Keynote ist in Englisch, denn Google ist aus Amerika. Macht Sinn. Er redet darüber, wie einfach es ist zu lernen, Google Clouds fortschrittliche ML AI Services wirksam einzusetzen, um AI-Potenzial auf alle Level des Businesses auszuweiten. Plus, Google zeigt euch ein paar coole Anwendungsfälle. Ich wünsche euch ganz, ganz viel Spaß damit.
Hello and welcome to this session on AI for All. My name is Eric Ballnath. I'm a customer engineer. I do architecture for customers and I'm located in the Google Frankfurt office. What I'd like to talk to you about is actually AI as a new era. What does it mean? What has changed? How does it impact our lives? AI at Alphabet, so the mothership of Google. Then AI is mostly machine learning. So this is not going to be deeply mathematical. It's more or less an overview about interesting resources to dig deeper into. And then how does the Google Cloud Platform support this with its data services and machine learning services? And then give you some examples. So we're definitely in a new era of AI, obviously, right? I mean, what used to be a big trend with mobile a couple of years back is now a reality. Nobody's talking about it. Everybody has everything on their smartphone. And now AI is here, and probably things like quantum computing, which we're also deeply invested in, are a topic for the future. Who here is aware of AlphaGo or has seen the movie AlphaGo? Right. So we're also in an age where computers actually surpass human intuition in the most complex game there is on this planet, which is Go. So chess is comparatively primitive against it, and this game was always known to be not solvable by computers actually, right? I mean, after a couple of moves, you would have more options than atoms in the universe, so nothing you can solve with brute force. But I'll get to DeepMind and AlphaGo in a minute. You can also use the AI and ML topics for really reasonable things, like saving a lot of energy. So all our data centers are actually making heavy use of ML models to save energy, which reduces like the consumption and the CO2 footprint enormously. And what also changes is that customers are actually expecting miracles, right? They're expecting self-learning, self-healing systems. Everything needs to be instant, like the known Google query needs to return in sub-second, or it's like disappointing. Zero touch, so what we call serverless. You don't want to think in servers and machines anymore. You just want to deal with a problem directly. Just quickly to Alphabet. Take a look at it. It's really interesting. It's actually the mothership of Google. So Alphabet has also some other interesting companies, which is, for example, here Sidewalk Labs. They make research on how megacities are supposed to look in the future, verily improving quality of life, Waymo self-driving cars, and Google X. So easy URL, abc.xyz. And then we have to the right all the Google companies with the known ones like YouTube and so forth. If you want to drill deeper into Google X, and all of these companies make heavy use of our AI tooling, take a look at x.company. It's quite interesting. So what are we here for, or what does Google do? Organize the world's information and make it universally accessible and useful. Everybody knows this prompt, actually, and the infrastructure behind it. So it's the biggest software-defined network in the world. It's a petabit scale network where we actually had to invent and build our own hardware and software for. Massive compute, mind-blowing storage, but also a lot of AI and ML models running behind this. And indeed, AI is infused in all of the services we do, even if you're not aware of it. For some examples that I'll show later on, you might be aware. So in these 9 Google services, they're all used by over 1 billion people per day. Each and every one of them makes use of massive ML models. What's the Google Cloud part of it? That's the part actually that contains all these big data, advanced analytics, machine learning services. It's G Suite, which is kind of the office part, not so relevant for this talk. Then we have Maps, Apigee, Anvato, but to the right, it's actually the cloud services. It's over 100, so just 9 showing here. And another change is that we can actually deal with very, very big data sets really well. I mean, you know this from queries that you run, right? They go over petabytes of data and they come back sub-second. What we're working on heavily is actually understanding the data. What does it mean semantically? Very high level probably, but nevertheless important. The common perception of ML is actually that you just collect a lot of data, then you have some fancy, miraculous models, and in the end you have a magic result in no time, right? Whereas the reality, of course, looks very different. You define your objectives and your baseline, you collect a lot of data, you need to understand the data deeply, you need to prepare the data, which takes about 80% of your time at least, create models, then iterate over these models, and then in the end serve them within intranet scope or to the web or wherever your customer base is, right? And we support this with quite some services. They're all very easy to set up. You just log in, you use the browser. There's actually nothing much to configure, no VMs to launch or dealing with network problems or anything like that. PubSub is something like a managed Kafka, you could say, right? This is the publish-subscribe service to ingest real-time data or data feeds, transfer service for very large data sets. Then you have data prepping, more or less, data warehousing and BigQuery. Who here has heard of BigQuery? Okay. Cloud storage, which will often be used as a data lake, so schema on read. And then you have the analytics part or the visualization part of it, and sheets. Also one of the more familiar ones, almost everything we do, we move into open source. There's actually 3 groups that you can do ML on the platform. You can bring your own data and use your own models by using VMs or Kubernetes clusters. You have to do it yourself. You have to figure it out yourself. Do all the management of the infrastructure yourself, except for BigQuery probably, which is a completely managed service. But you know your data, you know your model. Then there's this part, AutoML, where you bring your data, but you use actually mechanics that I'll dive deeper into, which use our models and our way to do automatic hyperparameter tuning and these things, for example. Or if you're a developer and you say, I want to use this intelligence, but I'm not an ML guy, I'm not a data scientist, you can just use pre-made APIs. You may know, for example, translation and others that you can directly tap into. So AutoML is quite interesting because if you think, what does a good data scientist do? He picks the right algorithms. He's good with dealing the data, wrangling the data into the right shape, identifying the right parameters, doing parameter tuning the right way, and all of this. But this could actually be done by a software, right? It would just run 20,000 cycles through different models with different permutations of these parameters and have these models compete against each other and pick the one with the best model performance, right? And that works really well. That even works on real-life data, so duplicate data, missing data, ambiguous data, and so forth. We did a nice hackathon recently where we actually wanted to train a model to identify or differentiate specific graffiti artists. In this case, Dime, who also made some artwork for us. And the challenge was actually making a mobile phone app that would actually categorize or find the artist for a specific artwork. So what you do in AutoML, you open the browser, you load images, which can be just folders named by the artist. In this case, we had 174, for example, for Dime and others. Can be a different number, can be different sizes, doesn't matter. You just load them. You click on train. Then you can evaluate the model. You see areas under the curve, accuracy, and these things, can do reruns and all of this, but it's actually just a couple of clicks. You can take a look at a confusion matrix, for example, and then deploy it to the app, where it's actually ML at the edge, so it runs on your device. You make a photo of the artist, and here you, for example, see you have 97% certainty that it's artwork of Dime, right? And that's actually very easy to do with very, very little coding. Another option to use this automatic service is AutoML tables, which is actually the same principle running on tabular data, right? So you would just load data sets, you would or the name column that you want to actually investigate on, and the system deal with the data most of the time. So it can handle imbalanced data, outliers, and all of these things. It identifies dates, email addresses, numbers, names, timestamps, and all of this, and can even correct them. So here's just a screenshot of loading data up here in the data sets. Then you would switch over to models. You can train the model, evaluate the model, would give you some insights about the feature importance that you have. All of this is done actually automatic. it's a very good start. If you really want to go super deep and you have very custom cases, you can actually start with this and then fine-tune and move on, for example, AI platform. Here again, the accuracy about it. Another option you can use is Jupyter Notebooks, managed Jupyter Notebooks. Actually, every service that we use in this regard is managed. So actually, nobody wants to deal with launching environments, VMs, and all of this. You just open the browser like you would do for Gmail or Maps or anything. Who's using Jupyter Notebooks? Yeah, okay. Again, open the browser. You can plug them into, for example, a Spark instance or read directly from cloud storage or from BigQuery. It all plugs in together like Lego blocks. Here's some different options you can use. You can use R environments, Python 2 and 3, TensorFlow. For TensorFlow, you can also switch to using TPUs, which are actually special ASIC units that are way faster than GPUs. So for training purposes, they're even faster than GPUs, which is a custom hardware that we actually built to support TensorFlow. But what about data? Data actually is the foundation of it all, right? I mean, the best algorithms, the best tools don't work if you don't have any data or can't deal with data properly. So data is super critical, super important, and it actually consumes a lot of time to deal with it properly. So in many cases, I would say these 80% is optimistic, because just understanding the data semantically can take a big chunk of time. So what you see here would be something like a Lambda architecture. That's an architecture built out of these Lego blocks that can deal with real-time data, coming in here through PubSub, for example, sensors, IoT devices, mobile devices, whatever it may be, going into data flow, and the same from cloud storage, so uploads of files that you have, XML, JSON, binary, whatever it may be. And you can use the same data flow because it can handle streaming data and batch data, bring it into BigQuery, and in BigQuery you can do your analytics. And another nice feature of BigQuery, although it's a SQL-based data warehouse, it can do inline machine learning. So within your SQL statement, you can actually train models and use models and evaluate models within your SQL statement, which is very convenient. You have data in place. You don't need to move it around to yet another ML system. All of this complexity, it's a very lean architecture where you can actually work with data in situ and can run your ML from the data warehouse. And then plug the other known tools onto it, like Tableau, Data Lab, Looker. This is an example you may know already or have tried. Who has tried Google Translate with a camera mode? Okay. Only a few. So it's very convenient when you're abroad and you want to read like traffic signs or whatever signs at a shop. What does closed mean or whatever? You can place your Google Translate app to it, and it will even be displayed on the camera image, right? Who has used words on photos, Google Photos? You just type something and it would find it. Yes, that's also a convenient version that few people know. These are actually in pre-trained models, but you can use the same functionality on what I showed on the right side with our data, our models. So currently, I mean, these things with overlays and detecting faces is actually quite old. But what could be helpful is, like you see on the top right, is understanding hand gestures. This is, for example, used with drones currently, or where you have like a new thing is a lamp that's at the same time a projector that goes to your table, and you can open up, for example, an invoice on the table, tap on it and say, pay this. And the system would like understand it, scan it, see the bank account and whatever, and do the transfer. So everything will be more voice-driven or gesture-driven, right? Conversational interfaces, of course. So if you use Dialogflow, you're actually capable of doing very, very powerful conversational interfaces. Spotify is actually doing almost everything, not only storing data, managing accounts and music, but also doing analytics on the music and on the nature of music and similarities of the music on GCP. And next topic that is quite interesting, I mentioned AlphaGo in the beginning, is reinforcement learning. So AlphaGo actually learned playing well in the most complex game there is, which is Go, by itself actually, by playing against itself, by playing against other software in an unguided way, getting really, really better. This is nicely documented in the movie. Using reinforcement learning, so a concept actually where you have software agents and they interact with each other and with the environment they're in, and collecting feedback and changing their behavior to this. This is used a lot in game characters, that you actually drop into the game and they get smarter the longer they actually run around, play and investigate their environment. So this is something where you would use reinforcement learning a lot. AlphaGo, I mentioned it before. Take a look at it. Very interesting if you're deep into this topic of reinforcement learning, deep neural networks, and the combination on how they actually accomplish this. It's a hybrid approach. It's quite complex, but very interesting. And then last but not least, everything we do, all the technologies are open sourced sooner or later, so they're available on your notebook, but then need to be managed by you. The easier way is probably just logging into the browser and spend a couple of cents and using a managed environment, but that's up to you, so you're never locked in. And if you want to play around with data sets, do a bit of learning, or you have a nice business idea for a startup or whatever, the BigQuery data sets, most of them or many of them are actually free. So you can use NASA datasets, GitHub datasets, Stack Overflow. This is just a brief overview. There are many, many more. If you're curious, try everything out, fail a lot and try again. And that's it from my side. Any questions?
How far are you to implement your technology to operate on people?
Oh, yes. So a good point, medical applications. So there's this detecting functionality for mammographies, breast cancer detection, which is way more accurate than any doctor could actually check, because you can see like actually irregularities by just a couple of pixels, and the system would already alert, which is kind of an airbag, right? I mean, it would warn you. You would probably have a false positive for something that's not relevant, but at least you don't oversee anything like a human practitioner would, right? That's a big benefit. There's something with grüner Star. I have no idea what this is in English. This is an eye disease, actually, that can be detected early and prevents you from blindness. So in medical application, especially image recognition stuff is super, super powerful and really saving lives. So this is something where one of, for example, the Google X companies is doing a lot of research in.
I have a question that goes in the same direction. So medical applications, I know there are neuronal networks that you can train to recognize like protein binding sites and stuff like this. And I was wondering, you provide open source application, but then it's not relevant for research because you're taking data. Is there something that you're already collaborating on, or?
So I'm not in the medical space, but we cooperate with a lot of universities for this. And they own the data. We provide the tooling and they own the data, right? This medical data, patient data is a super strict topic, of course. I mean, there are really significant security applies. And the security we have on the platform is really leading edge. We could talk a day about it, on how it works. Yeah. But so these medical institutions, they own the data and there's lots of collaboration with them. And thank you.
Das war die Keynote von Google. Ich hoffe, es hat euch gefallen. Ich hoffe, ihr habt alles verstanden. Und wenn nicht, wofür gibt's den Google-Übersetzer? Wir sehen uns hoffentlich beim nächsten Mal. Schreibt uns gerne einen Kommentar oder lasst uns eine Bewertung auf Apple Podcasts da. Falls ihr noch andere Speaker, Firmen oder Themen habt, die euch interessieren und die ihr hier gerne hören wollt, schreibt uns das auch gerne als DM. Wir freuen uns auf jeden Fall auf eure Tipps und Vorschläge. Wir hören uns beim nächsten Mal und bis dahin. Bye.
ITCS, Pizzatime Podcast.